we're going to talk about how we can use the chain rule to take the derivative of the inverse of a function if we know the derivative of the original function. So how we kind of do this, let's think about what an inverse function is. Remember, an inverse function is a function that kind of undoes the original function. So for example, x squared, the inverse function is the square root of x. Now the fundamental rule of a function as inverse is that f composed with f inverse of x is just equal to x. So if we use that rule and take the derivative of both sides, we have to use the chain rule, but the chain rule would say that f prime and then composed with f inverse of x times the derivative of f inverse of x, so we'll just call that f inverse of x prime, is equal to the derivative of x, which is 1. So this right here is what we're trying to solve for. And we can solve for it and say that the derivative of f inverse of x is equal to 1 over the derivative of f composed with f inverse of x. Now, this will help us find the derivative of the natural log and log of any base. So if we think of the natural log of x as our inverse function, well, it's inverse to e to the x. So following this rule, the derivative of this is going to be 1 over, well, we take the derivative of e to the x, which is just e to the x, and we compose it with natural log of x. So we'd have e raised to the natural log of x. And e raised to the natural log of x is just x. So our derivative of natural log of x, which we could say, you may see this as d dx, the derivative of natural log of x is equal to 1 over x. Okay, and for log of any base, well, if we're talking about our inverse function as log base a of x, then the inverse function that we're starting with is a to the x. So our derivative here would be 1 over, remember the derivative of a to the x is a to the x natural log of a. So we would compose that with log base a of x. So we'd have a raised to log base a of x times natural log of a. And this term right here is just x. So our derivative for any base is 1 over x natural log of the base. Okay, so we're going to take the following derivatives, and you have to use the chain rule and everything else that we've learned so far. So here we have natural log of 3 over x. So the derivative of natural log is 1 over x, so we would first take 1 over 3 over x. Now we need to multiply by the derivative of 3 over x, which 3 over x is the same as 3x to the negative 1. So when we're multiplying by the derivative, we'd have negative 3x to the negative 2. Now simplifying this, 1 over 3 over x, that would be like dividing by 3 over x, which is multiplying by the reciprocal, x over 3, times negative 3 over x squared. So this actually simplifies to negative 1 over x. Okay, next we have a quotient that involves a natural log of x. So we have natural log of x divided by 1 plus natural log of x. So we'll use the quotient rule. So low d high, the derivative of natural log of x is 1 over x, minus high d low, which the derivative of 1 is 0, so we just have 1 over x, all over the bottom squared. Now you'll notice if we distribute this 1 over x, we get 1 over x plus natural log of x times 1 over x minus natural log of x times 1 over x all over 1 plus natural log of x squared. Well, these two terms cancel out, and the 1 over x will really become 1 over x times 1 plus natural log of x squared. So that would be h prime of x. Okay, and I probably should have listed some more here. Let's do one more example. Let's find the derivative. Let's let f of x be natural log of x squared plus 1. Well, the derivative of natural log is 1 over that thing. So the derivative here, we would start by doing 1 over what's inside, x squared plus 1. But then because of the chain rule, we would multiply by the derivative of the stuff inside, which the derivative of x squared plus 1 is 2x. So our derivative here would be 2x over x squared plus 1.